Hello, this will be a demonstration of Proposition 6 from Book 9 of Euclid's Elements, which says that if the square of any number is also a cube number, then the number itself will be a cube number as well. This is the converse of Proposition 9.3. We've seen that proposition a few times by now. That one says that if the side is cube, then the square is also cube. This is the converse, that if the square is cube, the side is therefore also cube. With that said, we're given a number a, and we're also given that the square of a is a cube number and calling that b. So a times a makes b, and the number b is a cube number. What we want to prove from this is that the number a itself is also a cube number. We're going to begin this by taking the product of a and b, calling that c. So a times b makes c. And it's just obvious that the number c is a cube number because it is the product of a and b. And we know from our given that a is equal to a squared. So c is really a times a squared, or a times a, which obviously makes it a cube number by the definition of cube numbers, which is definition 719. So c is a cube number. Next, we recognize that a times a makes b. We were given that, which then means by the definition of multiplication, which definition 715, that the unit measures a the same number of times that a measures b. But then by the definition of proportionality, definition 720, we can convert this into a proportion and say that the unit is to a just as a is to b. Now, for the same reasons, we can say that the unit is also to a just as b is to c. This would follow much like the previous step. Because a times b makes c, we had done that in our first step. It then means that the unit measures a the same number of times that b measures c. But then by the definition of proportionality, definition 720, we can convert this into a proportion and say that the unit is to a just as b is to c, which is what we've said here in our fourth step. But then what we have is we have two ratios, a to b and b to c, which are the same with the same ratio, namely the unit to a. Therefore, by a property of numbers, they are the same with one another, so that a is to b just as b is to c. We're also going to invert this proportion to say that b is to a just as c is to b. This is not something Euclid does, but I've done it here because I think it makes the next couple of steps a bit more clear. So with that said, b is to a just as c is to b. But we know the two numbers c and b, they are both cube numbers. We had proved that c is a cube number in our second step, and you know b is a cube number from our given. And we know from proposition 812 that between two cube numbers there are two mean proportionals, so that there are two mean proportionals between the cube number c and the cube number b. But we know c is to b just as b is to a. So we can say by proposition 8.8 that not only are there two mean proportionals between c and b, but there are also two mean proportionals between b and a. That's what proposition 8.8 tells us. But we know the number b is a cube number. We were given that. And we know that when two mean proportionals fall between two numbers, and the first one of them is a cube number, the second one is also a cube number. That's what proposition 823 tells us. So that because there are two mean proportionals between the two numbers b and a, and the first of those b is a cube number, we know that the number a is also a cube number, which is what we set out to prove, which means we're done with the proposition, therefore, etc., QED. Just to give an example with particular numbers, let's say that 8 squared makes 64. And 64 is a cube number. We know it is equal to 4 cubed. So this proposition then allows us to say is that 8 itself is also a cube number. And that's fairly obvious. It is equal to 2 cubed. So we see that this proposition holds. That's all I've got to say about this one. I hope you're not getting bored of these propositions. The logic is quite similar a lot of time, a lot of uses of 717 and 823 and 811 and 812 and converting statements about multiplication into proportions. It's a lot of the same stuff over and over again, but I hope you're still enjoying it. I hope I'm still giving you something valuable. I hope that you're still enjoying these videos. With that said, I'm going to end the video here and move on to Proposition 9.7.